Question 25c, Part 1. The orbits of Earth and Venus around the Sun are almost circular and in the same plane. Earth is 1.496 times 10 to the power of 8 kilometers from the Sun, and Venus is 1.082 times 10 to the power of 8 kilometers from the Sun. Treating the space between the orbits as an annulus, calculate its area. Write your answer in scientific notation correct to two significant figures. The area of the annulus is the area enclosed between the big circle, which is the orbit of Earth, and the small circle, which is the orbit of Venus. So the area of the big circle is equal to pi times the radius squared, and that's the radius of the orbit of Earth squared, which is 1.496 times 10 to the power of 8 in brackets squared. And that equals 7.030934624 times 10 to the power of 16 square kilometers. Now the area of the small circle, that's the area of the orbit of Venus, is equal to pi times 1.082 times 10 to the power of 8 in brackets squared, and that equals 3.677937918 times 10 to the power of 16 square kilometers. So to find the area of the annulus, we take this value here and subtract from that this value here. So 7.030934624 times 10 to the power of 16 minus 3.677937918 times 10 to the power of 16 is equal to 3.352996706 times 10 to the power of 16 square kilometers, and rounding that to two significant figures, that equals 3.4 times 10 to the power of 16 square kilometers. Part 2. Rearrange the formula for the area of an annulus, A equals pi times capital R squared minus R squared in brackets, to make capital R the subject. In the area formula for an annulus, capital R represents the area of the big circle and R represents the area of the little circle. So starting off with the formula for the area of an annulus, A equals pi times capital R squared minus R squared in brackets, the first step I'm going to do is to divide both sides of the equation by pi. So we have A over pi is equal to capital R squared minus R squared. The next step is to add R squared to both sides of the equation. In effect, moving this negative R squared over to the other side, we can turn this negative into a positive. So we have A over pi plus R squared is equal to capital R squared. Now capital R is to be the subject, so I'm going to swap both sides of the equation around. So we have capital R squared is equal to A over pi plus R squared. And finally, we need to do the inverse or the opposite of squaring capital R, which is to take the square root. So taking the square root of both sides of the equation, we have capital R is equal to the square root of A over pi plus R squared. Now note that only the positive square root is valid because we're referring to the radius of a circle and negative radii do not make sense. Part 3. A small metal washer is to be made in the shape of an annulus with inner radius 0.75 millimeters. The area of the face of the washer, shaded on the diagram, is to be 6.79 square millimeters. Calculate the outer radius correct to two decimal places. We are given that the inner radius of the washer is 0.75 millimeters and the area of the washer is 6.79 square millimeters. So using the formula from part 2, substituting R equals 0.75 for R and 6.79 for A, we have capital R, or the outer radius, is equal to the square root of 6.79 over pi plus 0.75 squared. And that equals 1.650401 and so on, which rounds to approximately 1.65 correct to two decimal places. Therefore, the outer radius of the washer is 1.65 millimeters.